Welcome to this IoT workshop. In this video, we will be using some different sensors. One of them is an ultrasonic distance sensor, and the other one is an humidity and temperature sensor, better known as the HT11. What we will accomplish with the usage of these sensors is to read the distance between our sensor and any object in front of it, and we will be reading the humidity, the temperature, and the heat index around the other sensor, the DHT11. Let me show you how this looks when it's implemented. Here you can see that we are using the same setup, our development board here, the power source that is not visible because I'm on top of it right now, but here we are using the DHT11 sensor. This is the humidity and temperature, and this is an ultrasonic sensor, better known as HC/SR04, or the eyes sensor, because it looks like a couple of eyes. So what this sensor do, it's very simple. This one, the ultrasonic one, is sending ultrasonic waves, and they are coming back to the sensor by reflecting with any object. So we can measure the distance between the sensor and any object. In this case, I'm just using a Raspberry, but it may be any other physical thing. The other one, the DHT11 sensor, just uses some internal circuits to detect humidity, temperature, and the heat index in there. So you can see so many different wires here. Don't worry about that. I will give you the details on how to connect them. So let's go into it just to learn how to implement this thing. Okay, first of all, the connections are right here. Let me show it to you. And let's see how this is connected. Here, well, let's go to the code here. Remember, we will be using some different libraries for our codes. So just keep in mind that every time that you see an include something like here, it means that we need to use a library. In previous videos, we already learned how to include these libraries into our Arduino IDE, and it's pretty simple. We just go to Tools, then we go to the Library Manager, and then we look for those libraries in order to them to be used. Then, here in the code, we can see some different lines. These three lines defines the connections between the ultrasonic sensor and the development board. Trigger pin is 22, echo pin is 23. We will see this on the diagram. And the max distance is an important number because if we go beyond 200 centimeters, it will show nothing. If I remember correctly, this sensor has the capacity to read 6 meters, so it's okay. So just use this 200 to be able to learn how to implement it. These two lines are used to the DHT sensor. The DHT pin variable is just to indicate where the reading pin of the sensor will be connected to our development board. And this one, the DHT type, is just to indicate what kind of sensor we are using. In this case, we are using the DHT11. Okay, so next, let's check something here. In these lines, the new pin and the DHT, we are just initiating some objects for the sensors to be used. The sonar is the ultrasonic sensor that we will be using, and we just have to indicate what's the trigger pin, the echo pin, and the max distance. And for the DHT library, we will be using this DHT object indicating the DHT pin and the DHT type. Okay, let's go to the diagram here. So here we have the development board, the ultrasonic sensor, and the DHT sensor. The most important part here is to use an external power supply and to wire it to the voltage and to the ground pins of each sensor here, like here, PCC and ground, and here the first one goes to power supply and ground to obviously the negative polarity. Just be sure that all your power lines in the protoboard are wired and correctly connected. Okay, so now this ultrasonic sensor has the trigger pin and the echo pin. As we just saw on the code, we are indicating that the trigger pin goes directly to the pin number 22, and this is the white wire, and the yellow wire is for the echo pin, so it goes from that pin to the pin number 23 in our development board. In the case of the DHT sensor, we are just connecting it via this purple wire to the pin number 14. It's that simple, don't worry about this wire mess, it's not that complex, just follow these connections and that will be enough for you to connect correctly your circuit. What happens if you don't know what pins to use? Okay, just refer to this image. This is the pinout, and this tells us what pins are available in our development board so we can connect them to different peripherals. So now here we are just initiating a serial communications as we already done before, and we are initiating the communication with the DHT sensor. Remember, we have two main functions in the code, the setup function and the void loop function. This void loop function is executing all the time during runtime. As long as the circuit is powered on, this will be looping one and another time. Something important here is that we are using a delay. This delay is in milliseconds, so we are making 1 second pauses for each run to be reading the variables. And all of this, we already know that we are using the serial console to print the values of the distance in this case. Here we are reading the humidity and the temperature from the sensor, the DHT, and we are using these two variables H and T. Then we have this to avoid some failures in case that the board is not able to communicate with the sensor. We will know that, and that may be due to a bad wire or something went wrong there. And finally, we just print those values on our serial console. Let me show you this serial console here. I will activate the auto scroll so you can see that it's looping, and I will clean it. So if I switch to this view, now on the left you can see the serial console, and on the right you can see my circuits. If I move this raspberry here, the values should change here in my console. Okay, now we have a reading of 11 centimeters. If I move the object a little bit away, the values in our console will change to 19 centimeters. Okay, something important here is that the minimum distance that the sensor can read, I think, is about 2 or 3 centimeters. So if I get the object so close to that will give us a bad reading. In this case, it's telling us that it's 3 centimeters away, but if we check here is not 3 centimeters away. So that's the little threshold that we need to respect. And that's it. I will move this away and my lectures will change to 17 in this case, 14, 13. So they will be just reading the variables and the distance between the sensor and the object. In the case of the ultrasonic sensor, the DHT sensor, this one, it is pretty simple. We just have to connect it and to read the values. If I leave this sensor just running the whole night and I log the data into some graphical representation, I may be able to see the differences between the temperature here in my office and the humidity, and that's pretty simple. So you have the code here. You can see that it's working. You can see how it's supposed to behave when you are implementing it. You can use any other object for this, and of course you will have the diagrams and the code. Here in the GitHub you will find the code to use, and you will find the connections diagram too. So you can follow up and just be ready to have some fun with this. So that's it for this video. These are a little bit more advanced sensors, but they are pretty easy to use. This workshop is just intended to show how many different variables we can measure, we can read from the environment, and then after learning how to code and how to wire these sensors, we maybe do something more interesting, such as sending that data to the cloud. That's it for today, and thank you.